Hello, everyone. It's time to start our event. Welcome, everyone. I'm Thomas, your host for this webinar. In a few seconds, I will let the stage to our speakers. I'd just like to mention that you are, which means that you can hear the speakers, but we cannot hear you. On the other hand, you can use the Q&A mode or the chat box to ask all your questions to our speakers. Feel free to ask as many questions as you want. They're here for that. They will just go through the presentation now, but they will answer all questions after the presentation. So we're here today to speak about arc fault detection devices, and I'll welcome on stage Duc and Nicolas. Floor is yours.
Okay, thank you a lot, Thomas, for the introductions.
Thank you, Thomas.
So, hi, bonjour, salam alaikum. Welcome you to webinar. Thank you all for coming today. My name is Duc. I am product marketing manager at Hager Group, based in France. I have been working several years in the electrical industry, and I love it. Today, I'm so happy to be here again with you to talk about our fault detection devices and technology with my colleague Nicolas Britsch.
Hello, everyone. My name is Nicolas, and I've been working at Hager for several years in R&D, in electrical distribution systems, engineering, and more especially on modular protection products like MCBs or RCDs, and since a few years as an expert in arc fault detection. As there are a lot of questions about arc fault technology, I'm very glad to participate to this webinar today and to have the opportunity to answer the most frequently asked questions. So welcome, everyone.
Okay, thank you, Nicolas, for your interesting introductions. I hope that we will have a good time and you will have a good time with us during this webinar. Before we get started, just a small information that we already made first webinar about AFDD, our fault detection device, but with the format storytelling. And you can go to our channel, Hager Middle East channel, YouTube channel, to get exclusive content and much more information about this subject. And today, during this webinar, we will present you in the different format. So frequently asked questions, which resume in 4 parts. The first one is warming up part. We will go quickly on the basic questions: what, why, how, when, where about arc fault detection devices, and then we will have a virtual demo AFDD against arc faults. We will unwrap different questions about standards, applications, and products. And then we will have questions concerning technology part about microprocessor, algorithm, artificial intelligence, about what we are doing, research and development in Hager. And of course, last but not least, the Q&A session with the exchange further with you. So let's start with the first part, warming up.
Okay, Duc. So we are here today to ask questions. So I have a first question for you. What is AFDD?
Okay, it's very simple question, basic, but it's very important to have a clear definitions of what is AFDD. According to IEC 62606, the product standard, the AFDD is defined as a device intended to mitigate the effects of arcing faults by disconnecting the circuit where an arc fault is detected. AFDD, arc fault detection device. And The AFDD use the microprocessors to identify characteristics that indicate an R fault and automatically trip the affected circuit. So there is the specific point of this AFDD with highly focus with a microprocessor and automations. So Nicolas, now we talk in the definition of AFDD about arcing faults. So what are arcing faults, please?
Yes, it's also important to know exactly what is an arcing fault. So an arc, as defined in the standard, the 62606 product standard, is a luminous discharge of electricity across an insulating medium, usually accompanied by partial volatilization of the electrodes. And an arcing fault is a dangerous, unintentional parallel or series arc between conductors. So here we made the distinction between two different kind of fault. The parallel arc fault is a fault between two conductors, two different conductors. Here it's phase and neutral on this example. And the series arc fault is a fault between two parts of the same conductor. So this is the very basic of arc fault, parallel and series arc fault are the two different kind of fault that we would like to protect. It's not only that, but we will see it later.
Okay, so what are the current values of arcing fault? Can you tell us a little bit further?
Yes, of course. First, you have to know that scientific studies have demonstrated that for series arc fault, it's very unlikely to have a start of a fire with current value lower than 2.5 amps. That's why the detection is starting from 2.5 amps and up to the rated current of the device. And this is for series arc fault. And according to the, once again, according to the standard, the product standard EN/EIC 62606. And then we are talking about parallel arc faults. Here the current values are a little bit higher, of course, because the fault is between two different conductors, so there are much more current. And in the standard, the test start from 17.5 amps and up to 500 amps for parallel arc fault between phase and neutral. There are another kind of fault, which is parallel arc fault between phase and earth. And here the current values are a little bit lower. And it starts from 5 amps and up to 75 amps. Okay, now that we know what are arc faults, Duc, can you tell us a little bit more why arc faults appear?
Okay, the arc fault appears. We can see different factors. Sorry, we can see that we have a kink or break in the cable wear due to frequent use, or we have a light damage resulting from drilling or construction work. We have incorrect or bad bending ready while stripping, or when we lose screw connections. Or after time, we have defective wear blocks, or sometimes rodent bites. So all of the factors damage the wiring, the system, the products, and its opportunity to create arc faults. And then from arc fault, it will create better damage like electrical fire. So Nicolas, we already talked about AFDD definitions, arc faults. Now, what is different between a short circuit and a parallel arc fault? I think it's interested by different aspect, different people to understand these questions.
Yes, exactly, because Sometimes people think that you are already protected with MCBs against parallel arc fault, but actually it's very two different kinds of situations. First, the short circuit is a direct contact between two conductors, so leading to a fast and high rise of current with a lot of energy able to move the magnetic subset of the circuit breaker in usually less than 5 milliseconds. So it's very high value of current in a very short time. And you have the graphic here that illustrates this. And parallel arc fault is the result of insulation damage leading to sporadic arcs repeating over time, but having enough energy to be able to start a fire. But usually not enough to trigger the magnetic protection of circuit breaker. And here below on this graphic, you have an example of a signal recorded during a parallel arc fault. And as you can see, the current value are very lower than, of course, short circuit. We are talking of, in this example, a peak value of 40 amps. And also the time window is much more longer, because here you have 500 milliseconds. So it's a fault that will repeat over time, but at the end it can lead to a fire, to an electrical fire, and that's why it's very important to use arc fault detection against this kind of fault, the parallel arc fault.
Okay, so we see now the difference between short circuit and arc fault. Then the question number 6 is, how do AFDDs identify arc faults in the circuit in order to order the chipping?
Yes, so the working principle is explained here on this graphic. And you have to know that AFDDs will continuously monitor electrical values measured from the protected circuit. These values will be converted into digital values and used to compute something we call secondary parameter. For example, the RMS value of the current is a secondary parameter because it's computed from the signal, the raw signal of the current. And these secondary parameters will be used and will be processed in a decision unit inside the microcontroller, and the result will be a decision to trip or not the device. And the new decision is computed every 10 milliseconds, which is an half cycle for 50 hertz electrical mains.
Yes.
And based on more than 350 secondary parameters. So at the end, the decision unit will tell to the electromechanical actuator if the product has to trip or not. Okay, so now we know what are arc faults. We know a little bit more how does it work. But still, I wonder, Dick, why do we need AFDD? Can you tell us a little bit more, please?
Yes, of course. Why we do need AFDD? Actually, let's take a look about electrical fire facts and figures. We may know that 2 million fires are reported in Europe every year. You can imagine a fire every 3 minutes in average. In terms of electrical fire, statistics estimate that from 20 to 30% of all domestic fires have an electrical root cause. 1,000 people are killed by electrical induced fires each year, and 6.2 billion lost each year due to damage of electrical induced fires. Electrical fires have a good proportion in electrical fires general speaking, fire in general speaking, and we have the cause of electrical fires that we already know are short circuit and overloads, leaking currents, lining, overvoltage, which is protected by MCBs, RCDs, SPDs, and POPs. However, we can see in the number 5 the arc faults, the dangerous electrical arcs, which is described and explained in the last questions, now protected and needed to be protected by AFDDs.
Okay. Can you explain us a little bit more what is the difference between AFDD and MCB RCD? So MCB for miniature circuit breaker and RCD for residual current devices.
Okay, it's a very pertinent questions. So now, first, we take a look about the functionality. The MCB between MCB, RCD, and R4 protection functions. We can see that the MCB protection functions against overload, short circuit in case of direct contact. The RCD protections protects in case of leakage and short circuit phase ground. And R4 protections complete the protection to protect against serial R4, parallel R4, and in case of Hager's AFDD, include overvoltage protections. Now, take a look and imagine that if we combine the MCB plus the AFD functions in one device and an RCBO plus an AFDD functions in one device, we will increase the level of protections. We maximize the prevention of electrical fire risk with own and complete type of faults. And we will go to a better level of protections. And we try to maximize that. We enhance the protection of our electrical system.
Okay. But if AFDDs are so cool products, why didn't we see them before? When were AFDDs created? Can you tell us a little bit more about the history of AFDD?
Yes, for sure. Actually, the AFDDs have, let's say, a friend, a brother, um, born in the United States. It's called AFCI, Foot Circuit Interrupters. During 20th century, there was a lot of number of electrical fires in the United States, and there was a lot of studies and research figuring out that um, there is a R4 was a big cause of electrical fire, and we need a device called AFCI to protect against this type of faults. So in 1996, the first draft of UN 1699 mentioned about AFCI. And the first version of next standard in 1999 um, described and require the AFCI mandatory starting from 2002 in the bedroom circuits. And starting from 2002 to 2008, a lot of evolution were made, and the AFCI type have more combinations and expand to 20 amp circuit in own family rooms. And in IRC world, in Europe, we decided to initiate the standardization work on AFDD in 2008. And the first version of the product standard on AFDD, for detection device, IEC 62606, were published in 2013. And 1 year later, the low voltage installation standard published and recommended AFDDs in final circuits. And at Hager, since 2016, we have our portfolio of offer and a lot of evolution made between 16 and today.
Okay. But in which countries are AFDD used today?
Very interesting questions. So here in the slide, you see example of some countries where national standards and in the country level recommend AFDDs and or use AFDDs already. So we can see AFCI in US, and then we can see in the leads, Germany, UK, Sweden. We can see Australia, China, European country in the east, of course France, Netherlands. And if we take example focused on Germany and United Kingdom, Germany, the country had the recommendations in their national standard, the VD 100 since 2016, and today AFDDs are widely used in Germany. They have a strong recommendation to use AFDD, and in United Kingdom, in the countries that where the British standard BS 7671 require recommend the use of AFDD as well, and it's ongoing a lot of project to push and to put a higher level of recommendation or go to the mandatory or requirement of AFDDs in these standards. To resume, AFDDs it's used and widely used in several countries, in US, in Europe, and I hope that in future, as it's a good and cool product, it can be used worldwide to have an more protection to prevent against fire risk, which cause a lot of damage for people and good. So we just finished the part one very quickly about basic information and questions about AFDD. Now we go to the part two with the virtual demo.
Okay, so we will go in the lab, isn't it?
Yes, exactly.
Okay.
Hi, now we are in Hager's lab. We're gonna have a demonstration how AFDD help to prevent fire risk ignited by electrical arc faults in a circuit with Nicolas.
Hi.
Hi Nicolas. I'm wondering, in order to demonstrate it, we need to create electrical arc faults. May we create the electrical arc faults? Example with two wires we're putting together like sparks.
No, actually, if you try to do it like this, the only thing you will get are small sparks, and there will not be enough energy in these sparks to start a fire. That's why we have to use a specific piece of cables which are prepared in a way to be sure that you have enough energy. This piece of wire has been prepared according to the standard. In the standard for AFDDs EN 62606, there is the description of how you have to prepare this piece of cable in order to be sure that you will have enough energy in the fault to start a fire. And in this case, the AFDD will have to detect this fault and to trip in order to protect the circuit. So let's test this piece of wire and see what happens.
So the wire has been put in the tester, and now we are ready to start the cable accelerated aging process. As described in the standard, we use high voltage in order to create a carbonized path. You can see some smoke coming out of the cable as high voltage has been applied. So here we will demonstrate the difference between an RCBO and an AFDD. First we will start with the AFDD, which will energize the circuit without any fault. The appliance, which is an electrical heater, on the right is powered on. And now we will insert the faulty cable in the circuit by switching the interrupter on the right. The AFDD has tripped at the moment the faulty cable has been inserted in the circuit. And if we try to close the AFDD on the fault, it will trip back very quickly. And now we remove the fault from the circuit, and we will use the RCBO instead of the AFDD to protect the circuit. And now let's insert the fault again to see what happens. As you can see, the RCBO is not able to detect this kind of fault, and we can imagine the damage to surrounding materials and the spread of fire to the building. Okay, I hope everyone enjoyed this little demonstration.
Yes, actually, we can see that when we have arc faults happening in the circuit, the RCBO cannot detect that, and it may create electrical fires, and it can get burn the buildings or our home or our electrical system if we do not have a dedicated device for this. So
Exactly.
AFDD in this case makes the role to detect, identify the arc faults, and to stop on the electrical risk, fire risk, and prevent against the damage and avoid a lot of bad consequences. Very nice. Thank you for your explanations, Nicolas.
You're welcome.
So now, what are the characteristics of an effort that you explain? I can hear in the video, but now you can show it in the slide. Different characteristics of an effort that the AFDD used to identify.
Yes, of course. But actually, as AFDDs are monitoring electrical characteristic, I think your question, Duke, will better be what are the electrical characteristics of an arc fault? And just to explain why we have to use electrical characteristic, because in the standard, there is a sentence who says the arcing current detection and release with regards to fire hazard shall be located between the incoming and the outgoing terminals of the AFDD. It means the detection has to be located somewhere here. So we cannot use other physical values like sound or like temperature. Or the only thing we can use are the electric signals which is coming through the AFDD. So what are the electrical characteristics of an arc fault? Here is an example of series arc fault recording. The first graphic on the top is the current signal as a function of the time, and the second graphic on the bottom is a spectrogram of the current. And there are 5 important electrical characteristics related to arc faults. The RMS value of the signal, as explained before, it has to be greater than 2.5 amp. Then specific waveforms like current extinction around the voltage zero crossing, as the arc extinguishes itself when the voltage is low. The irregularity of the signal also, because both for the current and for the spectrogram, this is very typical of an arc fault, because the arc is generated in an uncontrolled environment and will burn surrounding materials and therefore modify itself every half cycle. And then the presence of high frequencies disturbances, as we can see on the spectrogram, is also a very good characteristic of arc fault, especially when arc is burning through insulating materials. And finally, the duration of the fault, of course, we are looking for something repeating over time for several half cycles, not only one half cycle, which means thousands or hundreds of milliseconds, depending on the current value, because the more the current we have, the fastest the tripping shall be.
Okay, thank you for your explanations. So why it is not generally possible to get an arc fault trigger with homemade arc fault reproductions? That's my question in the video. If I create an arc at my home to see if AFDD protects, is this possible?
In the video, you managed to create a virtual arc fault. It was very nice, Duke. It was not real. But why is it generally not possible to get an arc fault trigger with homemade arc fault reproduction? Because in the standard, there is a test procedure which is described, and it also includes the preparation of cable specimens. And this is the result of scientific studies. So it requires specific equipment to perform accelerated aging of the cable specimens using high voltage sources. And the results gives a representative arc faults considered to be able to start a fire in a building. And usually, homemade tests are not able to generate such arc faults, but only sparks. And these kinds of sparks are not considered by AFDDs because we are looking here for something which has enough energy to be dangerous and to start a fire. So this is the reason why most of the time it's very difficult, almost impossible to get an arc fault trigger with a homemade arc fault reproduction.
Okay, so it's very clear, Nicolas. So the advice: do not do by yourself at home to play with this. Now the next questions, number 13. What is different between arc flash and arc fault?
Okay, this is also a question that we have sometimes. Arc flash is not the same phenomena as arc fault. Arc flash hazards occurs inside electrical equipment, such as a switchgear assembly, for example. And arc flash hazard detection is usually based on physical characteristics analysis, such as the temperature, the sound, the light, whereas arc fault detection is based on electrical signal analysis, as I told you before. And arc flash hazard detectors have to be located inside the equipment where the hazard is expected, whereas AFDDs, they can detect faults located dozens of meters along the running cables of a building. And here on the left, you have an example of a test, arc flash test. So without the arc flash protection, so you can see the kind of energy that you have in this kind of fault, which is much bigger than arc fault. Huh? And here below, you have an example of the Hager offer, which is called Hager arc, which is an active protection systems against arc flash hazards for luminous distribution system. So this is very not the same kind of fault. Arc flash is not the same as arc fault.
Okay, it's clear. Thank you, Nicolas. So we gonna go to the third party. So we will unwrap the next questions.
Okay. So Duke, a question for you. What are standards for AFDDs?
Okay, I love this question about standards. But very quick, as already mentioned, product standard, it's IEC 62606, plus amendment in 2017. We have installation standard, IEC 6364-4.42, recommend AFDDs, so for your informations. So we have here the three level, international, regional, national, and we come to country levels. That's important to understand as well in your countries. The national standard recommend or follow or have a similarity with regional or international, which recommends AFDD. So example of Germany with the DIN and VDE, with UK with the BS standard, and Sweden with the SS standard. Some example to see that the AFDDs are recommended in this standard.
Okay, but where do the standards recommend the installation of AFDDs exactly? Do you know the chapter?
Okay, I come to open my book
Bible.
and I will see the chapter 421.7 clearly recommended special measure to be taken against the effect of output in final circuit. So if you are in final circuit and you are in the location with sleeping accommodations, location with risk, a fire due to nature, processed or stored materials, example, woodworking shops, or location with combustible constructional materials, example, wooden building, in fire propagating structures, example, high-rise building, in location with enduring and irreplaceable goods, example, museum or library, you can install AFDD to prevent against electrical output and fire. You can see here an example which show that the AFDD combined with MCB or combined with RCBO can be installed in the final circuits to protect the bedrooms, kitchen, or light. You can put AFDD on all the circuit if you wish, or you can add your choice to select different final circuit to protect. Okay, so now it's my turn to ask question number 16. Why should AFDD protect final circuit, Nicolas? Mentioned in the standard. Why AFDD protects final circuits?
Okay, this question I think is also a question we have already in the chat. Huh? So I will answer it right now. So why should AFDDs protect final circuits? Because AFDD intends to be a final circuit protection device and placed at the origin of the circuit to be protected as required both by installation standard and product standard. So here you have the exact chapter of both standard where this is mentioned. But I think that you want also an explanation because okay, it's written in the standard, but why? Actually, this is for two reasons. This will allow the AFDD to maximize its working conditions in order to limit the exposure to external disturbances. Example given produced by the protected appliances of the circuit, and also to limit the mixed up signals to ensure the required level of protection. So it's both in order to be sure that we have a good protection and also to limit the probability to have disturbances and, for example, unwanted tripping.
Okay, it's very clear objective and it's very typical for our fault detection device. Thank you, Nicolas.
Okay, now a question for you, Duke. What are different types of Hager's AFDDs?
Okay, at Hager's, we are complete range portfolio of AFDD. We have two types, combined MCB and combined with RCBO. So we can see here that our product have the icon to easy identification of an AFDD with the other modular devices such as RCDs or MCBs. We have of course, compliant to IEC and EN standard, AFDD standard, and local standards, breaking capacity up to 10 Ka, curve BC, high current rating up to 40 amp. We have safety with test burden. We have as well the configurations with quick burst bar and quick connect, as well with bottom removability in order to ease on the installation and save time of installation. We have the FPN front product label for customization at your home, and we have QR code in order to contain all of information of the products.
Okay, Duke, thank you. Both products that you represent are phase and neutral products, but does the three phases AFDD exist?
Actually, it's a very good question. Do you know that in 2013, with the production standard IEC 62606, mentioned only single phase devices. The three-way devices only introduced later in the version 2017. But as the majority of the installations are provided with single phase final circuits because it's focused on the final circuits as explained. So we have only the single phase final circuit, and we focus on the protection of the final circuit with single phase as a majority. However, we will provide such kind of product in the future.
Okay.
So we already seen different aspects of the product outside. Now, what are AFDDs made of from inside, please, Nicolas?
So you want to have a look inside the product, of course. An AFDD is not just an arc fault detector. It has also conventional overload and short circuit protection on the MCB part here on the left. And sometimes also residual current protection. So you will see it in the next product. So this first kind of product is an MCB plus AFD product. And the arc fault protection can be identified thanks to the flame, which is located here, just above the test button. And of course, on the right side, you have the arc fault protection components, internal components. And let's have a deeper look inside. On the left side, you have, of course, the MCB, so the bimetal first, which will bend itself to trip the product according to the temperature rise created by the current flow. And then you have the magnetic coil here, which will create a magnetic field to move the actuator that will trip the product in case of short circuit. And then you have the current core of the AFD part, which will measure the current with high precision. And this will allow the detection of both series arc fault protection and parallel arc fault protection. Then on the MCB AFD, you have what we call a GF core, which will allow a function which is specific to the MCB AFD, which is the neutral crossing detection. And finally, we have the voltage measurement, which will allow the protection of overvoltage. If we talk about the RCBO plus AFD, we will have the same component on the MCB part, which are the bimetal and the magnetic coil for overload protection and overcurrent short circuit protection. But we will also find something else, which is dedicated for the residual current protection, residual current core, and relay, electromechanical relay. And on the AFD part, we will find the same component as before, but the only difference is that we don't have the use of the GF core, as the function of neutral crossing will be ensured by the RC core, which is located on the left side. Okay, I hope this is clear enough.
Yes, thank you. Very clear. And we will have maybe another support to figure out better that.
Yes, we'll have spoiler alert. We'll have another video just in few slides.
Yeah, exactly.
And what about the working and storage temperatures, Duke, of Hager's AFDDs? Can you tell us?
Yes.
Oops, sorry, I think just go back. Okay,
that's
sorry.
actually very quick. Our Hager's product, we have a working temperature up to 60 degrees Celsius, very high, and go down to minus 25 degrees. And for storage, it go up to 70 and down to minus 40 degrees for different region and different application for temperature, high temperature and low temperature. So, Nicolas, question 21. What are the different benefiting features of Hager's AFDD?
Okay, I propose that we watch a video in order to answer that. What do you think?
Let's go.
Let's go.
Hi, bonjour, salam alaikum, guten morgen, buongiorno, buenos dias, ni hao, xin chao, konnichiwa. Today, I'm gonna show you some of AFDDs made by Hager for detection devices. I'm bringing you two versions. This is AFDD combined with MCB. This one, it's AFDD combined with RCBO. Our offer are designed, tested, approved, and manufactured in Hager, France. Now I'm gonna show you a design of AFDD combined MCB. This product it's compliant to IEC EN 62606 standard and of course with the MCB standard. We have a complete range with high breaking capacity 6 kOhm and 10 kOhm. Variable chipping characteristics, curve B and C for circuit breaker. We have as well the high current rating up to 40 amps. We have different functions. Example, R-fault indicator, which help to ease the identification between the AFD function and an MCB functions. We have a tangle with robust and large in order to facilitate the operations which can connect with the other auxiliary devices. We have for product safety a test button for R-fault detection functions. We have a customizable solutions with FPN front product label, so when we open it we can put a label, the customer close it to customize the circuit. We have as well the facility for installations and operations for maintenance example with quick connect solutions and quick bus bar. I will make demonstrations for the quick bus bar. I put it in and I remove it. So it's very easy. It can save time for installations. We have as well the bottom we can remove easily. We can draw in the plastic piece and we can put it in for the DIN rail fixations. And then we have as well, last but not least, a QR code contains all the product informations and helps for the data tracking example. And now I would like to invite you to see inside of this product, and I will invite my colleague Nicolas Britsch. Because I like magics, I will try my magic tricks to teletransport Nicolas to come with us. Nicolas, please come. Hello, Nicolas.
Hello, Duke.
How are you doing?
Fine, thank you.
Thanks for coming. So we are here with AFDD products.
Yeah.
And we are curious to see inside of these products, the technology and how it's made.
No problem, I can show you. But we have to open it. Just step back a little, please.
Okay, it seems dangerous.
Now,
Whoa, unbelievable.
so here we have the product which is opened, and as you can see, we have two parts, two sides. The left side, which is the MCB side, and the right side, which is the arc fault detection side. On the left side, the MCB side, you will see conventional electromechanical parts. First, you have the magnetic coil for short circuit protection. You have the bimetal here for thermal protection in case of overload. You have the arc chamber in case of short circuit to extinguish arc. The terminals, and of course the contact here, which will close if I close the handle. And on the other side, here you have the arc fault part. I lost a piece. On this side here, the most important things are the current measurement cores. You have two cores. One is for the line current measurement, and the second is for residual current measurement. It's not a residual current protection, but it helps to analyze the circuit and the signals in order to perform arc fault protections. These two cores will produce electronic signals, and these signals will be measured by the microcontroller, which is located just behind this plastic part here. And the microcontroller will compute a lot of parameters, and it will decide if there is a dangerous situation related to arc faults. In this case, if the microcontroller identifies dangerous characteristics, it will actuate this component, which is the actuator, the electromechanical actuator, and this will open the product will open.
Okay, great.
So there is a lot of electronic inside. There is also a voltage measurement. There are also self-test components. It's a lot of electronics in order to perform fault detection.
Thanks for your explanations, and it's very interesting. To resume, we have a two side, right? One
Yes.
is the conventional MCB, so the circuit breaker, and the second one is electronic side, which measures, detects arc fault, and makes the decisions by microprocessor, latest technology, and so all of that, it's in one, all in one. Yes.
Exactly.
In Hager, we want to provide the best solutions, products, and services for our customer, and we want to be better every day. Thanks for watching the video, and see you soon. Bye bye.
Bye.
Okay.
Okay, so hope that the video it's a good moment for you, and you saw better products with this video, and I hope that you enjoy it. Now we go to the part 4, the techno part questions. So Nicolas, how do AFDDs avoid unwanted chippings?
Actually, embedded algorithm has been developed based on thousands of laboratory tests and field tests performed in actual buildings. So since 2015, hundreds of thousands of recordings that we call traces are has been performed during this test and have been used to improve the algorithm and make it very reliable against unwanted tripping. So the process to improve the algorithm and to develop the algorithm is the trace recording. Then we use dedicated software to perform algorithm simulation, and then we can improve the algorithm, update it, and finally go to the validation steps, and then we can release the product in the market.
Okay, so AFDD strip. When I use my hand tools, example drill, be with motors that generate internal arcs.
This is also a question that we have sometimes, and people are maybe afraid that it could happen. But as explained before, embedded algorithm has been developed based on thousands of laboratory tests, including, of course, normal operation linked to opening and closing of contacts, operation of a wide range of motors, including Britsch's sparking motors, operation of welding machines, switched mode power supplies, dimmers, LED drivers, lightning devices, and a lot more. And as Hager AFDD uses low frequencies analysis. It is also not influenced by high frequencies noises that we can find, for example, produced by power line communication devices. So there is no problem with this kind of appliances.
It's clear, thank you.
Okay, now a question for you, Duke. Why does it trip in case of HOANG neutral?
Okay, this question we already seen when you explain about the composition of our AFDD. So the wiring error can occur when electricians connect the wrong wire to the AFDD, neutral crossing. In our AFDDs, we can detect such kind of cross neutral situation as for every RCD used in final circuit protections. So cross neutral error, AFDD will chip when the load is switched on, thanks to the RC core and the GF core. So why does it chip in case of overvoltage situations?
Our AFDD brings an overvoltage protection function, which is based on the EN50 550 requirements, where the protection starts beginning from 217.5 volts. So the idea is that the higher the voltage is and the faster the product will trip. But why do we have an overvoltage protection? Because overvoltages can ignite fires on vulnerable appliances or appliances with poor internal self-protections. And as a fire protection device, AFDD will offer overvoltage protection for all appliances connected to the protected circuit. So that's the reason why we also embed this kind of protection. But talking about overvoltage and surge, for example, Duke, does an AFDD replace a surge arrestor?
Okay, so AFDD, sorry,
I
will do.
do it,
Sorry.
Duke.
So now we are here. So AFDD cannot replace a surge arrestor, but it can replace overvoltage at power frequency that Nicolas, you explained it. And with AFDD, you still need to use a surge protection devices. And we can use our range in Hager. We have as well this product, of course. So question number 27. Are AFDDs worth it for low consumption circuits?
The answer is yes, because parallel arc faults can always occur in every final circuit, including lightly loaded or low consumption circuit, because they are not related to the loads. And then AFDDs offers as well overvoltage protection for every load, as we already seen before, so including low consumption loads. But I think this question comes when we talk about series arc fault. So it is true that series arc fault are linked to the power consumption of loads of the circuit. But the circuit protection is defined according to the circuit configuration. Because you can never know if low consumption of one particular circuit in a building will still be true in the future, because the loads, they can always be changed and replaced. That's why, of course, AFDDs worth it for low consumptions.
Okay, thank you.
Duke, do I have to regularly test AFDDs?
Actually, the answer is no. But pay attention. We recommend and only recommend to push manual test button when you see here for RCD, but only once at initial setup. After the AFDD during the service life, will continuously perform self-test by itself automatically and will chip the contacts if something non-compliant is found. So it's totally automatic. And is there a direction of the wiring for AFDD's products?
Yes, there is a direction of wiring. AFDD versions, IRC or ARF references, are supposed to be bottom fed, whereas load circuit side is on the top. So as you can see, out means circuit side and in is the supply of the product, the incoming supply. This is mostly related to the overvoltage protection because the internal electronic components of the AFDD are supplied from the load side. And it means that they will be disconnected from the mains in case of tripping linked to overvoltage fault. And that's why we have to respect this direction of wiring in order to be sure that the electronic is disconnected from the power supply in case of overvoltage fault. Okay, Duke, a question also that came a lot of time. What should I do in case of tripping of an AFDD?
Okay, so we're talking about the identification of the kind of fault with AFDD when AFDD chips, right? So we have different indicators. You have yellow indicators help to um, identify if it is MCB chipping, RCD chipping, or AFD chipping. So you will know that when there is a fault in the network, you will know which kind of cause or a fault happens. And we have a step-by-step guide and all the relating support in order to help you during the life of AFDD. And it's very clear and very smart. The product can identify and give you a lot of information, necessary information for your operation. Now we come to the interesting question: technology. How artificial intelligence can improve the performance of AFDDs, especially in the Hager's AFDD, Nicolas?
Yes, you know that when we talk about decision algorithm and the big data processing also, comes the question of machine learning as obvious. Uh, because human-defined rules are very efficient, but they can take significant time to be developed, and sometimes they can become very complex and hard to update, especially when they use big data. And artificial neural networks, they are the most popular tools today used in machine learning in a wide range of different fields. And the idea is to have the same inputs and outputs as before. So the secondary parameter as an input and the decision to trip or not the product as an output. But the internal processing is performed by virtual neurons, and each one having their own coefficients automatically defined by in the learning step. Excuse me. So artificial neural network applied to AFDD are very promising, and we are performing research at Hager to use them. And the main expected benefits are the handling, to be able to handle big data, to automatically find the best possible rules, and also to simplify and enhance the update possibilities. But 2 points needs to be perfectly enlightened. The availability and the quality of data, because in order to perform machine learning, it is very important. And the development of the embedded platform also, because implementation of neural networks in microcontrollers is not as easy as in computers. And in addition, we have also the real-time computation constraint, which is, of course, very important and has to be guaranteed. But this is a very interesting field of research, and it seems very promising.
It's very interesting. Thank you. We count on us for better products and data analytics in the future, Nicolas. Thank
Yes.
you.
What benefits and supports can I get with Hager, Duke? Question for you.
Very quick. That it's a very usual question that customer can ask. What I can say the message here, it's Hager. When you come with Hager, you have a peace of mind from the product design, oriented installer, oriented customer, until the support. We have strong team support and resources to support you. We have as well tailored solutions to fit your project requirements. We have developed quick solution installation to save time and effort for you. We have it's very easy to order our product, is online, local wholesalers, or we have a warehouse in Hager in the countries, and we are supporting you worldwide at a family company with good quality products, and we're able to act as problem solving partner than a supplier, and we are present worldwide. So we can contact our sales representative to get support everywhere you want.
And finally, where can I find more information about AFDDs, Duke? And I think this will be our last question before starting the other question from the chat.
Yeah, exactly. So very quick, you can find our different channel, Hager Middle East website, YouTube channel, LinkedIn, your contact sales representative, or you can come to hager.com, different website in the countries as well. You can find all of the related support, video, promotion leaflet, catalog, as well the application guide, as well the only the information you need, or if you need further that you did not you cannot find in the places, you can contact our interlocutor.
Okay, now it's time for the question after the questions. After the question answered.
So hope that you still awake with us.
So I will read the question, Duke. 300 milliamps RCDs are considered extra safety for fire hazard. Are AFDDs simply more effective?
Actually, I can take this question. This is very interesting question, Christos Samuladas. The 300 milliamps RCDs, actually it's RCDs. It means the functions of RCD is to detect the earth fault, leakage earth fault. And the 300 milliamp type, effectively, it's to protect against a level of fire rate, extra safety, as you say, you can say that. However, AFDDs um, protects against arc fault, different type of fault. And today, RCD cannot detect in most of case. We need AFDD to complete the protections. But of course, the 300 milliamp RCDs are as well effective, efficient.
Okay, so this question, why can they be used in one circuits? Is it in order to avoid unwanted trippings, or they are not effective in multiple circuits? So this question, I think we have answered it during the session. The question related to the protection of multiple circuits. So of course, as we have said before, it is in order. It's first. It's written in the standard, but the reason is that it is in order to ensure a good level of protection as well as limit the exposure to disturbances. So RCD protection is still required for personal protection. Is the AFD connected before or after the RCD? I think this is a question for you, Luc.
I can take this question, of course, Nicolas. Indeed, very interesting question. I think we can, I don't know how to put because we had a lot of questions already, but we will try to adapt next time because effectively, before to answer that, our 33 question today sessions based on different experience, different question raised from you, from customer, from AFDD community. This one, to answer this, the RCD protection is still required for personal protection, yes. Is the AFD connected before or after the RCD? If you see the question, we focus on the final circuit. So standard require the final circuit protection. So at the level of final circuit, of course, you can protect combined AFD with RCD to have double protection. And in this case, we can use our product RCBO combined AFD. The AFD, in case if you want to use MCB plus AFD in your system, Of course, you can have the RCD in upstream to protect the differential current, and we have complete the short circuit with MCB and R4 with AFD. So I hope that is clear for you.
Okay, thank you. Luc, can we guarantee 100% no fire at all in the buildings where AFDD are installed? Or still fire can happen even after AFDDs are installed? I can answer this if you want.
Okay.
You can complete after if you want.
Yeah. Please.
So the arc protection first are dedicated to electrical fire risk. So of course, if it's not an electrical related fire, AFDDs, of course, we cannot protect. But still, the AFDD is here to improve, of course, the fire protection, the electrical fire protection. But it's not possible to guarantee 100%. But this is also true for every kind of protection. You can never guarantee 100% protection because there will still be some situation which it will be very complicated, for example, to detect the fault. But this is really small situations, and of course the standard is here to help to be sure that every product, every AFDD as they have the required level, good required level of protection in order to detect arc faults.
I just want to add a quick comment. Indeed, as Nicolas explained it, it's very clear. It's for electrical fire, the AFDD, and then especially for arc faults protections that we explained during the webinar. The other faults are still protected by MCB, RCDs, etc. One comment here, it's about 100% that you mentioned in the question. Indeed, we follow the product standard ICEN 6206 strictly with all the type tests. And we have a test with different type of arc faults, and we have as well the endurance test. So to test the reliability of the algorithm and the product, and of course we pass and certify it. So on that we can have a good proof. However, as Nicolas explained, depending on the situation, you say a no fire, it's a very we cannot be precise. No fire, it's very large. It's very difficult to say. Hope that it's clear for you.
So what about three phases? I think we already answered that. Maybe the question has been raised before. Is there an indicative power consumption? Milliwatt, etc.
Yes, we have an indicative power consumption routine in the consumption of AFDD, right? We have on the detailed data depending on the versions of AFDD, but it's very low. If you wish, you can send me the question back in email, and I can send it to you to information, or you can contact your local interlocutor.
So just maybe to give an idea, I think it's less than 0.5 watts for one AFDD. So it's very, very low, and good efforts have been put in order to develop a very low consumption product.
Okay, Luc. We're done with all the different questions. Thanks a lot to all of you who attended to this event. I would like just to encourage you to take a minute to give us your feedback after this webinar, so that we can always improve the experience for the next sessions. And I'd just like to invite you to follow us on LinkedIn and visit our websites to make sure you won't miss the next webinar sessions. Thanks a lot. Enjoy the rest of the day and the rest of the week. Thank you.
Thank you. Bye bye.
Bye bye.
Bye.
Thank you, everyone, and bye bye. See you.